In this video, I will be giving a progress update on the MBAR rifle build. The first part I'm going to go over is the barrel assembly, which is now complete. On both of these barrels, I have the gas system and the piston system mounted. I have a Yankee Hill machining flash hider that takes a hub suppressor mount. And the base barrel for both is a Faxon Match Series heavy flute barrel. This one is in 223 Willed, and this one is 308 Winchester. The way the barrel mounts work is there are two variants, one for the AR-15 sized barrel extension and one for the DPMS pattern barrel extension. The way each one works is it opens up like a clamshell, and it has cutouts for the ring and the indexing notch in the barrel extension. The DPMS pattern is pretty much the same, except the clamshell opens up further along due to the fact that the DPMS pattern barrel extension is a bit longer. So these two were the old ones. They are slightly out of spec, and then there was a bit of wobble when I put the barrel inside of it, so I ended up remaking them and adding some improvements to them. So I've got the AR-15 barrel assembly here, and the piston rod holder is still the same, except now I've added 4 holes for 4 M3 screws to go through and add tension to the clamshell to have a stronger mount. I've also used some barrel shims. This is for the AR-15 and this is for the DPMS that I've stuck in between the ring right here to just give it a bit of a tighter fit. I put one in each one of these. All right, now so I'm going to show you how to mount this into the upper receiver. The lower receiver is currently configured for the 5.56 version, so I'm just going to use this barrel assembly right now. One thing I want to show you before I put the barrel assembly in is there is a latch right here for the non-reciprocating charging handle to be used as a forward assist. And there's a little ramp right there that moves it up and down so that it will disengage when the charging handle is in the forwardmost position and when the bolt carrier is in battery. So to put the barrel assembly in, you want to insert it from the bottom, like so. And there is a radiused pocket right here so that this thing will, the screws on the outside that clamp into it will keep this thing very secure, and you won't have problems with the screws on the side stripping. So to secure it in place fully, I'm going to use 8 M4 countersunk torque screws and just put 4 on each side. Just like when you're changing the tire of a car, you don't want to tighten all of them all the way at once. So I'm going to put them almost in and then tighten them at the end, just like when you change the tire of a car. Now I'm going to put the upper plate in the bottom of the upper receiver. This part exists because it would be impossible to have this closed off and still be able to insert the barrel from the bottom, and it would also be extremely hard to machine it that way. So I'll explain more for what this part specifically does in the next video, where I go over the fire control system. But for now, I'm just gonna slide this in linearly from the front, and it just snaps on in place. And then I'm gonna take the handguard right here, slide it on through the front, and then screw it in these this spot right here, and the same thing on the other side. So the handguard screws in and keeps this plate captive. And the handguard is also free float, so this will be as accurate as the barrel you select for your build. All right, now if I look at the front of this thing, I'm trying to just bend the barrel, and it has a very, very solid fit, so this thing should be quite accurate. You may get a bit of accuracy penalty because I'm using a short stroke gas piston, but I wanted to use 18-inch barrels so that I could get a rifle length system to sort of mitigate that. And I think between that and the fact that this has a constant recoil system in the back, I think the recoil and accuracy should be fairly manageable. Since last time, I've also added a buffer assembly. The design for that is complete. Unfortunately, I don't have the parts fully made yet, so I can't show that in this video. But what I will be showing now is how to mate the upper and lower receiver. All right, so I've got the lower receiver here, and as you can see, there are 4 slots right here, and that corresponds to the 4 hooks over here. So to put this thing together, all you have to do is just line up the hooks with the slots, and then push it up and then back. You want to push it back until the end of both the receivers line up in the back. Once you're done with that, you take the stock plate right here, which just slides on up. There is a indent here for the recoil spring to sit in. The recoil spring guide assembly is finished, but I'm still trying to decide on a spring. This looks like it's going to have to be a custom part, so I'm playing around with the spring constant and the parameters to give it a good spring. So I'm going to slide this thing on up. Oh, by the way, this hole right here lines up with this one here, and then that's for the takedown pin to slide into, and that's what keeps the whole thing together. So I'm going to push this up from the bottom. And then I'm going to take my takedown pin and just push it in from the back. And now it's together. So there's another feature that some of you have probably guessed at. which is um, how do you fix a malfunction on this? So the only other rifle, the only other bullpup rifle that does downward ejection is the Keltec RDB. And a big problem with that is because the ejection port is moved from typically this spot here to down here, you can't look into the chamber to see if it's loaded, and you can't see any jams. So to clear a malfunction, you probably have to disassemble the rifle. So I'm going to insert the magazine here. There is no bolts. So some people have probably guessed this already, but there is an inspection slot at the top right here. So this black thing right here is actually the top of the non-reciprocating charging handle. And when I pull the charging handle back, it opens up so that you can see into the chamber. So you can see the magazine, you can see the bolt lugs, and I purposely made this large enough that you could stick your finger inside or use a Leatherman multi-tool to clear a jam. For example, the pliers on a multi-tool. So this will stay closed when the bolt is cycling on its own, because again, it's a non-reciprocating charging handle. But it will automatically open up when you pull it back. So you can very quickly just see if you got a round in the chamber, you know, like press checking it just like you would on like a handgun or any other rifle. And, you know, you can just hold it back to, you know, clear a jam. I think this is a very important feature that without it, the downward ejection system would simply just not work. All right, now the only thing left to do at this point is to put in the recoil spring system and the bolt carrier, but neither of these are fully complete. I need to get the correct spring for this, as I said earlier, and I'm still missing a few parts on the bolt carrier, mostly for the buffer system. So I'm going to take this time now to answer some frequently asked questions that I got from Reddit and email. When those other two things are finished, the bolt carrier and recoil spring, I'll be posting another update. That will likely be my final one before I test fire it. So once I get that, I'll do a function check on video. I'll probably take a blank round, drill a hole through it, and pour out the powder so that I can safely test fire this thing indoors to make sure the fire control system works. So the next video will basically just be the bolt carrier, the fire control system, and that's pretty much the last part of this thing that I need to, you know, fit and test to get it working. Another question I got from viewers was overall length and length of pull. So as you can see, I've angled the stock of this by 15 degrees, just like the Steyr AUG has, to sort of decrease the felt's length of pull on this thing due to it being longer than usual. So as you can see, it's just over 13 inches. It's just maybe like 1/8 of an inch longer than on the Steyr AUG. For the overall length, I have an 18-inch barrel in here. So I'm going to measure it from the very back of the stock to the end of the, or where the end of the barrel threads go. And I won't include all of the muzzle device, since for length measurement purposes, the government typically doesn't count that. So I'm getting around 30 inches. So basically take your barrel length and add 12 inches to it. So another thing people asked about was the barrels. So why did I use AR-15, AR-10 barrels, bolts, and cam pins? The reason why is because it just gives you more customization options than using proprietary systems. The ACR failed, in my opinion, because of the proprietary barrel assemblies that they just couldn't make enough barrel assembly kits for every single caliber barrel profile that people want, right? So with this system, this barrel mount creates a common interface for both the AR-15 and the DPMS pattern barrels, so that they'll all fit into the upper receiver in like the same area, right? So with this, you can get a carbon fiber barrel, you can get a pencil barrel or a heavy flute like I've got here. You can get it in 6.5 Creedmoor or a 300 hammer, and you don't really need any tools to change it out. You can just change it out by taking out these screws like I showed you earlier in this video. Other people asked about the gas system. So this is just the standard short stroke gas piston that you would find on pretty much any other modern rifle. I got three settings here. Right now it's in the standard configuration. If you turn it by 45 degrees, it goes into suppressed, and then if you turn it another 45 degrees, it goes to adverse. So the reason why I had to design a custom gas block for this is because the distance from the center of the barrel to the center of the piston needed to be exactly 22 millimeters. I thought that was probably different from most AR gas blocks. But this is not something that I can patent. That's not something I want to patent either. The concept of a short stroke gas piston is so old that everybody's using it. So I'll probably release the specs for that so other companies can make gas blocks for this, so they can be as available and customizable as the AR-15 ones, where you can just pick up any one and stick it on a barrel. So these ones are made for the 0.75 inch gas profiles, and I'll probably have to make a 0.875 one later. Oh, and some people asked about why I chose a short stroke piston. The reason why is because I felt a long stroke piston like you have on the DeVore compromises accuracy a bit too much. It's got a lot of recoil. It is more reliable, yes, but I think this is also fairly reliable as well. With the internal piston, or what some people call the direct impingement system on the AR-15, there were a few problems with that. One, like we all know, the fact that you have to clean your AR-15 much more often is kind of a problem, especially if you're running it suppressed. It also transfers a lot more heat back into there, which is something I didn't want. A lot of the problems with gas blowback going to your face, I fixed with the downward ejection system. I didn't want to make that problem worse by using the direct impingement system on the AR-15. And then other people also brought up the Perun system, where they use a gas tube going back, and basically you move the short stroke piston to this area right here. I also ruled that option out because that option requires raising the top rail by quite a bit. So now your height over bore, and this one, I think it's like pretty high, but it's going to get even higher, right? So that would be a problem. And also, the other issue is I noticed that the gas tube on many AR-15s is generally a point of failure, especially when you get to the extremely high round counts when you're firing the weapon like fully cyclic. I think most people probably wouldn't get the benefit of avoiding that choice because they're not, shooting their guns that much. But I can see some situations where if this is being used in a professional capacity, that use case would benefit the user, especially like in a military setting. Finally, I think some people asked about the downward ejection. So the downward ejection system on here was critical to the design of a bullpup. My belief is without downward ejection, like no bullpup is really going to be comparable with traditional rifles. And the reason why is because even on the designs where you have it going from the side here, or the side right here, either the right or left side, you can change it with like a tool, like on the Tavor or on the Desert Tech. The problem is it's still going out on one side or the other. Sometimes you may need to switch it very quickly, like if you're going around a corner. And I think this is a use case more for, like a military setting. But when you're in combat, you simply just cannot pull out your tools and change it back and forth. You need to just be able to, have a version that just works in all situations like this. And this has the added benefit of, again, eliminating the gas blowback that goes into your face, which is a problem with AR-15s and other weapons like that. But it gets considerably worse on a bullpup, regardless of which side it's on. And I added this thing right here to stay closed. Just to give you all the benefits of having the window and just keeping the gas out of your face. So with the downward ejection system, the bolt carrier just moves twice its own length. It moves, like it travels a lot more distance, right? So because of that, you also get another unintended benefit, which is you now get constant recoil. What most people don't realize is most of the recoil on a semi-automatic or automatic rifle comes from the bolt carrier slamming into the rear plate of the gun at the very end of its travel. And you can mitigate that with like a really good buffer. But what if we just completely eliminated that by having it just touch it very, very slowly or not at all, right? And that's the concept of constant recoil. If you're familiar with the Ultimax machine gun or the Knights Armament LM or LAMG. So because I had to move it back further to get the downward ejection, so like this, the constant recoil just came in accidentally, right? And I figured that would just be a benefit. Some of my viewers did mention putting in a buffer. Initially, I kind of just I thought maybe just make it more simple. Just don't put that in. But I figured if you overgas the rifle, you probably still want to have the buffer in there just to, just in case, to reduce that like last tiny bit of possible recoil. So between that and the long stroke system, I think that I've pretty much done everything I can to have the like minimum possible recoil on this design. So this video is getting a bit long. I'll probably cut it off here, and if there's any other questions or anything else I want to show, I'll probably put that in a follow-on video. In my next one, I'll probably show me like wearing this with a plate carrier and just kind of demonstrating the ergonomics, like the reloads and stuff like that. Yeah, please like and subscribe. Follow me on X. I just made that recently. I have a website up and running now where you can get the files to 3D print a lot of these parts. So for example, this and this. So yeah, just please like and subscribe. See you in the next one.